Alright, so for this video I am giving you an example of standard 7 and I'll give you a couple of examples of standard 15. So take a minute to read it. Oh, and it got chopped off on the right, I just noticed. It says find its linear speed in miles per hour. Okay, so that's what's missing on the side there. So right here I have the formula. The linear velocity equals the radius times its angular velocity. The radius was given to you, and this was given to you. Now this is not omega, but we can find omega by using this information. So 500 revolutions per minute could be converted to omega by multiplying by 1 revolution for 2 pi, every 2 pi radians. So that's gone. So it's going to be 1,000 pi radians per minute. So omega is 1,000 pi radians per minute. Okay, so now we have R here and omega here. That's going to help us find V. So V is 2.4 inches times 1,000 pi radians per minute. Now the problem is, now this is a perfectly acceptable linear speed, inches per minute, but the instructions say that they want the answer in miles per hour. Okay, so we've got to convert this to miles per hour. So you know that there are 12 inches in 1 foot. There are 5,280 feet in 1 mile. And we've got to convert minutes to hours. 60 minutes in 1 hour. Okay, and when you go through, inches and inches cancel out, minute and minute cancel out, feet and feet cancel out, and radian, again, it's a unitless number. So what you have left is miles per hour, which is exactly what you need. So now all you have to do is take your calculator and input these numbers and figure it out. Now what I like to do is reduce the 60 and the 12. So I'm going to make 12 goes into 60 5 times. So on your calculator, 2.4 times 1,000 pi times 5 divided by 5,280, and that's going to be miles per hour. Alright, so I input in my calculator and I get 7.139, and it keeps going. So I'll round it off to the nearest tenth, so 7.1 miles per hour. Alright, here's another problem for standard 7. You're riding your bike at 32 miles per hour. At what revolutions per minute are the wheels spinning if the diameter of the wheels is 26 inches? So I went ahead and wrote down the formula right here that we're going to be using. They told you the diameter and they told you the linear velocity. So that means that we're looking for omega, but it's not going to be in radians per minute, but they want it in revolution per minute. Okay, the answer. So first thing we're going to do is get the R. Okay, and then to solve for omega, we have to divide both sides by R. So omega is velocity divided by radius. So 32 miles per hour divided by 13 inches. Okay, so I'm going to have to convert the linear unit, miles and inches, to one or the other. So I'll just convert the miles to inches. So 1 mile is 5,280 feet, and 1 foot, 12 inches. So with that, I can cancel miles, miles, feet, feet, and inches, inches. Okay? Now I have to convert hours to, we call it to minutes. So 1 hour, 60 minutes. So I can cancel hour, hour. So the only unit I have is blank divided by minutes. Okay? So that's omega. It's actually radians divided by minutes. Radians over minutes. So you're going to take your calculator and let's see, I can do the 12 here and 5 here just to make it less numbers. So I put it into the calculator. So I multiplied this one times this one, and then when you simplify this complex fraction, because you notice how you have a fraction in the numerator, it becomes this when you simplify it. So since you're dividing by 13, you're actually multiplying by 1 over 13, so you end up with the 13 right here next to the 5. So you put that into the calculator and you get this, right? So now I don't want radians per minute, I want revolutions per minute. So I know that 1 revolution is 2 pi radians. Okay, so now I'm going to divide 2,599, and the dot, right here, that just means that I didn't round, I just kept the number that's on the screen. So I'm going to divide by 2 pi. And remember, if you're going to divide by 2 pi, that you need to put parentheses around the 2 pi so your calculator knows that those are together in the numerator, in the denominator. Okay, so let me see something. I put something wrong here. Alright, so then this means that it's going to be 413.7 RPMs, revolutions per minute. So for standard 15, this is one way I can ask you the question where I give you the function, a value of a function, and then I give you the inequality, like this one right here. And I ask you for one of the functions. So in this case, I'm asking for cosine. Okay, so we know that tangent is positive because the 1/4 is positive. So I'm going to go ahead and mark the quadrants where tangent is positive. So that would be in quadrant 1, quadrant 3. Then I'm going to go ahead and mark the plane where sine is negative. Now I know sine is negative because it's less than 0. That's given to you. So sine is negative here and here. So then the quadrant where you have the 2 dots would be quadrant 3. So that allows you to draw the angle in the right quadrant. So this is theta. And then we form a right triangle always to the x-axis. Excuse me. And tangent is 1 over 4. Remember, tangent is y over x. So that means y 1, x 4. But because it's in quadrant 3, we know both of them are negative. And then Pythagorean theorem, negative 1 squared plus negative 4 squared gives you 17. So this is going to be radical 17. And so radical 17, and cosine is x over r. So that's going to be negative 4 over radical 17. We rationalize it and get negative 4 radical 17 over 17 as your answer. Now another way I can give you the question is by giving you the quadrant, like right here. It's telling you directly where it is, where the angle is, and then giving you another function to find a second function. So I know that if theta is between pi over 2 and pi, I know that it's in quadrant 2. Okay, so here's theta. So I'm going to draw a right triangle to the x-axis. Definition of secant is r over x. So r is 5, x is negative 2. Excuse my dog. So to find y, because I need the y, I need the vertical distance so that I can find tangent, I use Pythagorean theorem. Now in this case, we're not going to add 5 squared and negative 2 squared because we're missing one of the legs. So negative 2 squared plus y squared equals 5 squared. 4 plus equals 25. So I'm subtracting 4 from both sides, so y squared is 21, square root, and we take the positive because it's in quadrant 2, so this is square root of 21 up here. So tangent is y over x. So y is radical 21, x is negative 2, and that's your value. Alright, so here's a third example. I know cosine is positive because it's a positive 4/9. So positive cosine would be here and here. Cotangent is negative, again because it's less than 0, that's a negative number. Cotangent is negative here and here. So then the two dots are in quadrant 4, so both conditions are satisfied in quadrant 4. So that's where your angle goes. Okay, so here's your angle. And so we form a right triangle to the x-axis. Cosine is x over r. So here's 4, here's 9. So for y, it's going to be 4 squared plus y squared equals 9 squared, 1681. So y squared equals 65. And the y would be negative because it's in quadrant 4. So then this would be negative square root of 65. Now it's asking for cosecant. Now cosecant is r over y. Okay, because it's a reciprocal sign. So r is 9. So cosecant 9 over negative square root of 65. Okay, so rationalize it. Negative 9 radical 65 over 65. And it doesn't reduce or simplify anymore, so there's your answer.